Bismillahirrahmanirrahim. Now this is question June 2019 on mathematical induction. Okay. You are given the series and then by induction method you want to prove that all the series, okay, the summation of this equals to n plus 1 n plus 5 over 3. Okay, so this is the question. So the first step is you need to let everything here to be your Pn, okay, because we want to conclude later on it is in terms of Pn. Okay, and then we need to check for, okay, this is for P1. Okay, we need to check whether P1 is true or not. Okay, so P1 here is true or not. Just replace everything here with 1, okay, here and here also. Then you are going to check whether you get the same answer for left and right hand side. So this one is 4 and this is also 4. Okay, therefore P1 is true. Once P1 is true, then we can proceed to the next step. Okay, so the next step will be the assumption that PK is also true. Okay, so we want to assume that PK is true. Okay, I need to show part of that. Okay, so that everything here you just need to replace. Okay, replace what? Replace this K and with K. So here is K plus 3 and this is K plus 1. Okay, with K plus 5 over 3. Okay. When we assume that PK is true, so the next assumption, when PK is true, so PK plus 1 also need to be true. Okay, so we need to find the value of PK plus 1. Okay, so just find for PK plus 1 now. Okay, everything here. Okay, plus until here you will get, okay, in the K term you will replace with K plus 1. So K plus 1 plus 3. And here is K plus 1. So K plus 1 plus 1. Okay, so you will get K plus 2. K plus 1 plus 5. So you will get K plus 6. This is over 3. Okay, so this one. Okay, for this one, you need to know this one, okay, these things. Okay, jap. This one, the one in red, this one known as PK. Okay, the last term for K, PK. And this part, okay, this part, oh sorry, this one should be equals to. Okay, so this one should be the one in blue, TK plus 1. Okay, the term of K plus 1. And what we want to show is the addition of this PK with this TK, you need to add these two, must be equals to this PK plus 1. Okay, so that's the thing that we want to show. Okay, so now, okay, we will show the step of addition of that lah. Okay, so we will prove for PK plus 1 should be equals to PK and then TK plus 1. Okay, so that the value of PK just now it is, okay, K plus 1, K plus 5 over 3. Okay, and then total with TK, K plus 1. So here will give you K plus 4. Right. Okay, so K plus 1 and K plus 4, we want to show whether this goes to these terms or not, this one. Okay, so we are going to simplify for this. So the first step, maybe we can equating the denominator, meaning that multiply here with 3 and 3. Okay, so that we can get here for k plus 1, k plus 5, just copy. And with this one is 3, k plus 1, k plus 4, divide by 3. Okay, combine that. So next is whether you want to expand or factorize. But factorize is simpler. You can reduce the number of steps. So let's check what is the common term. Okay, so we have k plus 1 here and also k plus 1 here. Right, okay. So now we can bring this k plus 1 in front of the term. Okay, so what's left? It should be k and k plus 5 with 3 and k plus 4. Okay, so this one over 3. So we will try to expand and factor after that. So this part is k square plus 5k, 3k plus 12 over 3. So here is k square plus with 8k plus 12. Okay, so we will check whether these terms we can factor or not. So k square plus 8k plus 12, factor for this, you will get k plus 2 and also k plus 6. Okay, you can manually factorize or use the calculator. So now this is the value of, after we simplify, this is the term. Okay, so now we will compare whether this is equals to these terms or not. Okay, so k plus 1, k plus 2 and k plus 6 over 3. Yes, so these two are equal. Okay, meaning that you already show the left hand side is equals to right hand side of the term. Okay, or we show that these terms, okay, pk plus tk plus 1 is equals to pk plus 1. Okay, therefore what we can conclude, okay, so the conclusion here, pk plus 1, okay, is also true for all k elements of positive integers. Okay, therefore Pn is true for all positive integers. Okay, with that we settle for the first part of the question. Okay, this is for A. Okay, second question B given is, by using the result in part A, evaluate. Okay, so the question asks you to evaluate 4 plus 10 plus 18 plus until 130. Okay, so you want to evaluate this using the previous result. So the information given in A, so I will rewrite here, is 1, 4, 2, 5, 3, 6 until over 3. Okay, so we want to evaluate. As you can see, this one 4, 10, 18, okay, equivalence to all these values. Okay, until what? Until n plus 3. Okay, so that this information given the last term. Okay, so given to you the last term, but we don't know this 130 at what term. Okay, this is first term, second term, third term, but we don't know how many terms exist here until we can get 130. Okay, so we can use the formula for this. Okay, the formula of Tn. Okay, this is actually the formula for Tn, the last one. Okay, so n plus 3 will be equals to 130. So from that we can get the value of n first. So n squared plus 3n minus 130 equals to 0. And then need to factor, so that it will be n minus 10 and also n plus 13. so that the answer is 10 and 13. Okay, so this is the number of terms should be positive, negative. Should be positive. Therefore, we are going to choose n equals to 10. Okay, so once we get this value, n is equals to 10, we can now replace in terms of this equation. Okay, so that all the things given, 4 plus 10 plus 18 plus until 130 will be equals to 10. 10 plus 1, okay, that one is 11. 10 plus 5, it is 15. Divide with 3. Okay, so you will calculate for this, and then the summations of the first term until 180 will be equals to 550. Okay, with that we settle for this question.